Okay guys, so like you know, we're covering a new unit. We're covering Unit 2, which deals with all sorts of things about cell theory and what it means to be alive, and also what we find in there is properties of water. And so you guys did a lot of these experiments on the properties of water during class. However, I'm just going to make a quick little video to remind you of the properties of water I will have you held responsible for on the test or anything for the purposes of my class. So let us begin. So when we're dealing with water, we need to understand that water has two bonds that play a very crucial role in it. And the first one that I want to talk about deals with bonds that happen within the molecule itself, within the H2O. And these particular bonds we call polar covalent bonds. So understand that they are polar because that they create two different charges. So think about the globe and how we have two poles. We have the North Pole and we have the South Pole, and they're both very different from each other. Well, molecules that are polar, they also have two poles, except what we classify them as different depends on the charge of the pole. And so I had made the example in class of how one of the students that was a very, very large student was bonding with a student that maybe was a little bit smaller than that student. And I had them bond by holding an electron or a tennis ball in between them to show the bond. And so they were holding these tennis balls in between them to show the covalent bond or the sharing. What I had one of the larger students do was take the ball a little bit closer to them, away from the smaller person. And this was supposed to show what happens with oxygen and hydrogen. So oxygen's like that big person, that big boy or whatever. It will, when it's bonded to hydrogen covalently, remember they're sharing an electron, but since it's so much bigger than hydrogen, it's going to want to hold the electron a little bit closer to it versus the hydrogen. And since the hydrogen is weaker in this sense, it's not going to be able to ward off the oxygen's hogging. So all of a sudden, since our electron is negative, right, electrons are negative, our oxygen is going to be a little bit more negative. And the reason being is because he gets a little bit more of the electron than the hydrogen does. So this creates an overall partial negative charge. And the hydrogen then, in turn, is what we say is a little bit partial positive, right? Because the electron is farther away from it, and since the electron is negative and it doesn't have it close to it, it's going to be more positive than the oxygen. So that's where we get this creation of these poles. And we call these bonds that have this polarity polar covalent bonds. Now when we're talking about hydrogen bonds, we're not talking about just one molecule. We're talking about the interaction amongst many molecules. So in my picture over here, I have all these water molecules together. And you can see that the positive end of the water molecules in this picture, I have one with a hydrogen, its positive end is going to be attracted to the negative end of another water molecule. And it's this attraction, they form a bond, a weak bond, but we call these bonds hydrogen bonds. And so what I had you guys do as a fun little way to remember what hydrogen bonds are is the slogan, hydrogen bonding is bond, F-O-N. So only fluorine, oxygen, and nitrogen are capable of hydrogen bonding. If they have hydrogens attached to them, they can hydrogen bond. So this is what I mean by hydrogen bonding. It's just simply the attraction across two different molecules. It's the attraction of their poles, their positive and their negative end. Okay? So I have a cute little picture up here that has a water molecule saying to a fat molecule, I'm sorry, we just can't be together. And the fat molecule turns around crying, says, it's because I'm fat. And the way that this is supposed to show is since water is polar, we say that polar molecules can dissolve other polar molecules. Like dissolves like, okay? And in terms of fat, well, fat's not polar. Fat is actually classified as nonpolar. So polar and nonpolar molecules don't like each other. They don't mix very well. If you've ever dropped oil in water, you know this fact. It doesn't like to mix because fat is nonpolar. Also, if we say something doesn't like water, we say that it is hydrophobic, meaning it is water-hating or water-fearing. It doesn't like water. If it's hydrophilic, it means it does like water. So water-loving or water-liking. So properties of water, the next part I want you to know is water is classified as the universal solvent. And what I mean by that is water has the ability to dissolve many things into it. And so when we're talking about solutes and solvents, we say that solvents are anything that dissolves something into it, okay? So if I were to have a bunch of particles, and I give you the example of like Kool-Aid. If I were to take Kool-Aid, I would say Kool-Aid is my solute because it's the particles that I want to dissolve. So I'm going to pour the Kool-Aid into a glass of water. And it's when I pour it into the glass of water that water all of a sudden becomes the solvent, because it's what I'm trying to dissolve my solute in. Okay? And always remember that there is more solvent than there are solute. That's usually a rule of thumb. You want to have more solvent than you do solute. And so again, water is considered the universal solvent because it can dissolve a lot of things. It can dissolve Kool-Aid, sugar, salt, lots of different things. And so that's why it's considered the universal solvent. Okay, I'm working on cohesion, adhesion, and surface tension. And so again, I had given examples in class of all three of these, but really it boils down to cohesion is water attracted to other water molecules. Okay, so water likes itself. It's attracted to itself. It wants to be around itself. And because of that, it has cohesive properties, cohesion. This is why water, when you see it get dropped onto a desk or anything, it'll kind of bead up. It's because it's attracted to itself, so it'll try and get close to itself. On the flip side, though, water is also attracted to other molecules and other material. And so its attraction to other things, we call this adhesion, right? So it wants to be attracted to the desk. It wants to be attracted to the glass of my water. It wants to be attracted to my straw. And so what it'll do is it'll try to climb up these straws, or it'll try to climb up the cup. And when that does that, we call this capillary action, meaning it is traveling, it's moving, because it's adhering to something else. It's attracted there. And so cohesion and adhesion together, they help create kind of a surface area, okay? And this surface area has tension to it, right? Because water's attracted to itself, but at the same time it's attracted to other things. There's a tension there. And so this surface tension is actually really important when it comes to certain water bugs and lots of creatures that we have in the world. So to elaborate on this capillary action, I also want you to think of capillary's importance when it comes to like plants. So plants all have roots, and roots aid very much in the capillary action of plants. It tries to take up the water through this adhesion. Okay, the last property of water I want you guys to be familiar with is density. And so water is one of the very, very few things out there that when it solidifies or freezes, it will actually be less dense than its liquid form. It is said to be less dense. And when we say less dense, we simply mean by these two pictures that I have here. If I were to look at my fluid cup of water, okay, and I have down here, I have my cup of water, and all of my water molecules are moving around at random. They're all in my cup, they're all on top of each other, they're all spread out, no really rhyme or reason. And this is when water's in its liquid form. However, when water is actually in a solid form, it forms these like water-like lattices due to hydrogen bonding, okay? And they form these really elaborate geometric structures that have lots of space in between them. And it's this space, this spreading out of the water molecules that are allowing ice or solid water to begin to float, okay, to make it feel like it's almost lighter than the liquid portion, because things are more spread out. They're less condensed on top of each other. So with that said, the 5 properties of water I want you to be aware of is universal solvent, adhesion, cohesion, polarity, and density. Water is less dense than its liquid form when it's solid. And so as long as you know these 5, you should be good to go for the purposes of my class.